Hello Algebra 2 students, and welcome back to Chapter 9. Today we are going to be doing 9.5, okay, and this is going to be day 1. We're going to kind of conquer all the little tiny intricacies for graphing rational functions. And we are going to do a test over just graphing, okay, so we're going to do 9.5, day 1, then day 2. Then we're going to have a review / test day. Okay. So as I go through here, you're going to need all these notes down. So you need to pause the video and write down all of these notes. We're going to start here with some x-intercepts. To find the x-intercepts, which are important when graphing, okay, x-intercepts are where the graph crosses the x-axis. We know this, right? Because it hits the x-axis, we know that the y will be 0. All right. Now, when you're thinking about this, the only time I care about anything is, well, here a rational function, we should probably figure out what this rational function is. A rational function is a ratio of polynomials. Okay, and if I'm thinking about when will a ratio be equal to 0, so we're thinking about when a ratio is going to be equal to 0. Well, if I just made one up, this would be such a ratio. Okay, and because this is usually equal to y, and we just talked about the idea that the y on the x-axis is 0, then this is a 0. Well, clearly when I multiply this bottom over, that times 0 is still going to be 0, so I only care when the top is 0. So in this case here, I would get x equals 4, and my answer would be 4, 0. Okay. Now you could have to do a bunch of these. Alright, you could have to do a bunch of these, but that's the general case. Y-intercepts then is where it hits the y-axis. Now this is where the y-axis is crossed, right? Which means that x here is 0. And we've done this many times. Okay, this is where we substitute 0 in for all of the x's. Okay. So on my last example, I had y equals x minus 4 over x squared minus 5. That was the same example. Here would be plugging in zeros. And of course that would give me 0 minus 4, that would be a negative 4 up top. 0 squared is 0, minus 5 would be a negative 5. So my intercept would be at 4, 5, and we write it as 0, 4 fifths. And we've done stuff like that before. A key note here, there will only ever be only one y-intercept. There should only ever be one y-intercept. There can be multiple x-intercepts. Then we get into this brand new thing called an asymptote. Okay, you've never seen this before. An asymptote is a line, in general, is a line that cannot be crossed. When we talk about vertical asymptotes, we're talking about vertical lines on a graph, right, that we're going to get close to, right, approaches, but we will never touch it. Okay. Of course, well, how would you get these? Well, this is the values that make the denominator equal to 0. Okay. These are values that we know as like excluded values. These are values that we cannot have. We cannot be dividing by 0. When we do, we create this vertical asymptote. Okay, so what do? Well, we're going to set the denominator equal to 0, and then we're going to solve it. On the example that I've had here in the past, this was the example I had. I would take this bottom, set it equal to 0, and if I solved it, square root. Oh, I drew the square root, so it's x equals plus or minus square root of 5. These would be two vertical lines at positive square roots of 5, which this number, right, the square root of 5 is in between 2 and 3, so it would look something like this. That would be the positive version. This would be x equals positive square roots of 5. And then over here, I would have x equals negative square roots of 5. Okay. But for now, all we really need to do is we need to find these two equations there. So those are the start of the notes. Well, if we have vertical asymptotes, right? We have this vertical asymptote, then clearly we're probably going to have horizontal. Again, hopefully you're pausing the videos before I start writing and you're really getting this stuff down. So I have horizontal asymptotes now is the horizontal line that gets approached but is never crossed or touched. Okay. Now, this is known as an in behavior. Okay. This is an in behavior asymptote, which means that I can't cross it at the ends. Okay, I can do stuff in the middle, but I can't do anything at the very, very end. Okay. It's really unimportant to have that down completely, but just know that these are known as in asymptotes, in behavior asymptotes. How we determine where they are is we will be comparing the degrees of the numerator and the denominator. Okay, which I have this little equation here. If I go back to the one that we've had before, right? This is the one I've had so far. In this case here, m would be this one, right? X to the first. And n would be this 2. So this should kind of help you with the visual here. Okay, and now we have this table. All right, we got this table, which it states a couple different things now. If the numerator, well, let's not drew it up there. Let's actually try to get it inside there. So I'm going to need probably a thinner marker. So here, if the numerator degree is less than the denominator, okay, the degrees now, if it's less than that, then I'm going to have the y equals 0. Okay, I'm going to have that case. And if the numerator degree equals the denominator, then we have this special case here, where I have to take the first thing on the top that's connected with the degree divided by the first thing on the bottom that's connected with the degree, which of course we know those as the leading coefficients. Okay. In the other case here, we don't have to worry about when the numerator is greater than the denominator. That's a pre-calc topic that you'll be covering next year. Okay. So if I go back up here to my little example here, I had a 1 and a 2. What you'll see me do a lot is I'll do 1 compared to 2. Well, 1 is less than 2. Oh, well then which case is this? Over here I had case 1, case 2, and case 3. Well, I have 1 is less than 2. Oh, numerator is less than the denominator. That's case 1, which means for my example here, I would have a horizontal asymptote at y equals 0. And again, if I were to draw this, here would be the plane. Oh, y equals 0 would be right on the axis. Okay. Now, it is super important that you get all those notes down, not including these. Okay, you don't need this down. We're going to wait until day 2 to do that. Alright, but all the other stuff that I hit on, you need down. This purple stuff is just so important in the last couple slides, okay? It's super important to get that stuff down. And we're off onto the examples. Okay, here on the examples, having them written down is very wise. Okay, But in general, I think we can kind of figure this thing out too. But you could pause the video right now and you could try to copy down my examples. Now, it says, I want to know the x-intercepts. Well, where are the x-intercepts? An x-intercept is where it crosses the x-axis, this line right here, right? So I think it hits in that spot right there. Well, where is this point? It looks like it's like right on 0, 0. Now, that was the x-intercept. It doesn't hit ever again on this line here as I'm tracing it, right? You see my pencil there. But now when I move to the y, right, the y-intercept, I'm looking at this line, right, and I'm tracing it down. Where does it hit? Oh, well, it hits at, looks like the same spot, 0, 0. Of course, that shouldn't shock you because I have these zeros. Okay. Now, the next thing is it says a vertical asymptote. Vertical. Okay, that means up and down. That means when I draw it, it should be up and down. And remember, asymptote means that it can't cross it. So where does it look like the graph never hits, but it looks like it's getting close to it vertically? Right? Like what I could do is I could almost draw right. There's my vertical line. Yeah, I tried to make it as straight as I could. Okay, and I draw it. Now clearly I said that the asymptote shouldn't hit it. It's hitting it right there. So maybe I just keep going. Drag it, drag it, drag it. And right here it looks like it shouldn't be hitting it. Right? I get that I didn't draw this perfectly straight, but down here my blue line here shouldn't get and actually hit that. It looks like it just gets closer and closer to it. Same with this one up here. Well, where's that line that I just drew, that pink line? That was at x equals 1. It's right there at x equals 1. Of course, it's an x because it does go up and down. And then we tried to tackle the horizontal asymptote. Well, that means that it's a horizontal line, right? So maybe I'll just draw one of those, a horizontal line. Now, it said that it's an asymptote, right? So it shouldn't hit it. So if I were to drag this, right, when does it hit a spot where it doesn't touch the graph, but it looks like the graph gets closer and closer? I think it's like right in there. If I were to keep going down, now it's hitting the blue graph. So it's like right in there. Well, where's that at? Well, it looks like that's at, well, it looks like it's at y equals 3. Of course, it's a horizontal line, so it should be a y equals. And there we have our very first example. That one I took quite a bit of time on. This next one I think I'll try to move a little bit quicker. Here, same type of example. Okay, I'll go after the x-intercept first. It looks like the x-intercept hits like maybe like right there. Where would that be? That looks like at -2.5. 0. And if I'm going after the y-intercept, oh, now I'm looking at the y-axis. It looks like it hits right there. Where's that at? That looks like pretty much right on 1, 0. Okay, that's not too bad. Now again, with the vertical asymptote, you can think about drawing a vertical line. That wasn't a great line. Maybe I'll try to redraw that. Okay, you can draw a vertical line. Now remember though, it's where it doesn't hit. So where does it not hit? Well, right in there, right? What's that at? That looks like it's at x equals -6. Same thing with the horizontal. This one's a little bit trickier to kind of see, but I think it's probably like right in here where I'm drawing it. Okay, now there is some wiggle room here, right? We don't have the equation, so we have to kind of guesstimate. But I think it looks like it's maybe just right there at 2. So this is y equals 2. Those first couple kind of just give you a visual on what these graphs are going to end up looking like and finding those 4 things. Now what I want to do is I want to find all those things, but without a graph. I just have an equation. Okay. So here what you should do is you should copy down my example and the directions. Pause the video, copy it down. We're going to find the x-intercept, the y-intercept, the vertical asymptote and the horizontal asymptote. Okay. Alright, now that you've had a chance to write down, copy down the example, I will kind of show you the process that I like to go through here. First thing is I like to do the x-intercepts. I'll try to kind of color code this here. The x-intercepts occur when the top equals 0. So I set x minus 3 equals 0, and I solve that and I get x equals 3. Well, what does an x-intercept look like? Well, it's a point. If it's on the x-axis, that means the y has to be 0. What's the x? Well, it's that 3 that I just got. Okay, shouldn't be too hard. The y-intercepts, how do you find the y-intercepts? Well, the y-intercepts are when let me get this other stuff out of here, is when I have a 0 for the x. Oh, x is 0. Well, then plug in 0 for the x's. What would I have there? I'd have 0 minus 3 over 0 squared plus 3 times 0 plus 2, which gives me a negative 3 over, what, 2? Oh, negative 3 halves. Okay. Again, I think I'll kind of get rid of that stuff after I use it. And I did that one there in green. Okay, just moving right along. The next thing I like to do is the vertical asymptotes. How do I get that? This one here, again, this is new. This is where you're taking the bottom, the denominator, and you're setting it equal to 0. When I do that, I think this factors. Do I know factors of 2 that add to 3? Well, yeah, that'd be a 2 and a 1. They both need to be positive. Set it equal to 0. Use the 0 product property, which is x plus 2 equals 0, x plus 1 equals 0. I get x equals negative 2 or x equals negative 1. There are 2 asymptotes here, so I have to write them both out. There are 2 of them. This is the only way to write it, just like this. It has to be written x equals. Okay, well, we're off to a pretty good start then so far. Now we have, oh, how many colors do I have left? I guess I haven't used blue. Blue will do the horizontal. For the horizontal, I have to compare the numerator degree to the denominator degree. Well, the degree up here is a 1, so I got a 1, and it's a 2 down here, so 1 to compare to 2. 1 is less than 2. This goes back to the cases that we had. Earlier, we wrote this stuff down. 1 was less than 2. Oh, that's this first case. Oh, that means that y equals 0. So over here, I have a horizontal asymptote at y equals 0. Okay, I should only have one. I should only ever have one horizontal asymptote. I should only ever have one y-intercept. But that means that these other ones, right, I can have multiple x-intercepts and multiple vertical asymptotes. Alrighty, so we're on to the next one. These look like the same directions, just a different example. Okay, just a different example. Again, wise to pause the video, get it written down. Alright, this next one here, I'll try to keep the same color coding that I had before. So I think I did this one here in green. The x-intercept, well, I take the top and I set it equal to 0. When does 5 equal 0? Never. Oh, well, then there's just no x-intercepts. That wasn't that hard. Some of you really want to try to make that version right there that really difficult. It is as simple as doing the top equals 0. If it can't, then there aren't any. Now the y-intercepts, well, that's when I plug a 0 in for the x. Okay, well then that's 5 over 2 times 0 plus 1. Well, that would be 5 over 1, which is equal to 5. So this is a 5. Okay, and I should only have one here, so I found the one. I'm done. The vertical asymptotes, I think I did it in purple last time. The vertical asymptotes, how do I do that? Well, I take the bottom and I set it equal to 0. So that's 2x plus 1 equals 0. That's 2x equals negative 1. That's x equals negative 1/2. These always are x equals, so this is x equals negative 1/2. Feel good about that. Moving on to the horizontal asymptote. I compare the numerator to the denominator in their degrees. Well, the numerator, this is x to the 0, so it's 0 really, compared to, oh, that's 1. 0 is less than 1. That's case number 1, which is y equals 0. Again, great time now to pause the video. Make sure you're really understanding what just happened there. I have this example here that I want to do, and then I'm actually going to do this guy here, this one here, and this one here. We're kind of going to overload us with a bunch of these here at the start in hopes that front loading these will make the second day much easier. Okay, right now we're coming up on 2 minutes. That's not too bad. I want to get this video done in 30 minutes. I think 30 minutes would be a good video here. So here we go. We got y-intercepts. You set the top equal to 0. That does factor. 2x, x. I need to make 13. I would need a 5 here. That would make 10. And then a 3 here. Oh, that would make my 13. Plus, plus. 0 product property again, so I'd solve this. This one would give me a negative 5. This one would give me a negative 3 over 2. My x-intercepts, remember, are always the number 0 and then the number 0. So I have 2 of them. Okay, that doesn't seem too hard. The y-intercept, I'm plugging in 0 for my x. Well, that would make this a 0, and this is 0, and this is 0. Well, really, that just gets rid of this and this. So I have 15 over negative 9, which I think simplifies to 5 over 3, and it's negative. I should only have one of these. I can have multiple x-intercepts, but only one y-intercept. Alright, well, let's clean this up a little bit. I don't want all this stuff on there. For the vertical asymptotes, I take the bottom and I set it equal to 0. Well, that's x squared minus 9 equals 0. Well, that's x squared equals 9. A bunch of you are going to square root it. Do not forget that that's x equals plus or minus 3. There are 2 vertical asymptotes here. Finally, I get to the horizontal asymptote. I'm taking, again, remember, this is the numerator degree versus the denominator degree. That's a 2 versus 2. 2 versus 2, those are the same. If they're the same like this, that's where we're taking A over B. Well, what's A? A is this 2 here, so it's 2 over B would be the number out here. Well, that's a 1, so it's 2 over 1, which is y equals 2. And there we have our example number 3. Last couple things here. It says sketch the asymptote, state the domain and range. Okay. Here it doesn't tell me that I have to find anything else. So I could find the asymptotes algebraically, right, using what we just did there, which really wouldn't be too bad. Here, when I do the vertical one, I'd take this equal to 0. Well, that means that x equals negative 3. Well, let's see if that backs up our claim here. Like, look at our graph. It doesn't hit that dotted line, that dashed line. So that is an asymptote. And it did tell me to sketch them, so I have to do that drawing in there. Now, for the horizontal, I'm taking this one compared to that one. 1 compared to 1. Oh, those are equal. Because they're equal, I'm taking the numbers out in front of them, which are just so happens to be 1 and 1. That's 1 divided by 1, so I have y equals 1. If I were to graph that, That's this green line here. The graph does not hit it, so I do feel pretty good about the horizontal asymptotes. Now we're just onto the domain. Domain. Well, how far to the left does this graph travel, right? If I draw a little line here, what kind of a line do I want to draw? Okay, here I'll try to indicate like I usually do in class with my hand, right? Imagine this is my hand. I'm thinking, how far to the left does this graph go? How far can I keep dragging this? Well, of course, it's supposed to continue forever. Well, what's forever in math? Well, we know forever in math is negative infinity when it goes to the left. Can't touch that, right? So now I continue, right? I'm going to the right, but then you see how this like climbs up? But notice, I can't just trace. If I'm on this blue, I'm tracing upward, right? I keep going and to the right, but I can't cross this vertical asymptote because I have to like somehow jump way over here. When I have to jump, we've done this actually before. Where do I have to jump? Well, I have to jump over this vertical asymptote at the 3. The -3 here. So at -3 I got to stop. Now we said that we can't actually touch that. So we need a parenthesis. Then I need to union it. Oh, well, technically it picks right back up, right? Because this one's super close down here. It goes from -3 then to, well, then it would be over here on this other one, right? And then how far to the right does it go? Well, it goes forever. And forever in math is infinity. Can't touch that. So notice that the jump occurs down here at my vertical asymptote for the domain. The vertical asymptote is made up of an x. The domain are made up of x's, and it jumps at that value. When we look at the horizontal asymptote, okay, we're looking at the horizontal one now. Same type of thing here. If I start with this green one, I would be drawing it downward. How low is it going to go? Well, remember, you're tracing it. This blue continues downward. Because it continues downward forever, I have to say that this goes down forever. Can't touch that, right? Now it comes up. It's traveling upward, right? I'm dragging this green line upward. It's traveling upward. But right here I get a sticky spot, and I can't hit this line. Well, where's that line at? That is at my horizontal asymptote. Oh, well, that's at 1. I can't touch it, but it will pick right back up at 1. Again, it's the same type of logic here. That is going right in here. Okay, the union happens at my asymptote. Then after I jump over that, right, after I make it over that, it jumps up top here to this blue line, and then I just continue upward. When I'm continuing upward, of course, that means that I'm going up for forever. Okay. I'm going to do one more here, and then we're going to call it done for this video. Okay. So, same type of thing going on here. It says that I want to sketch the asymptotes, right? Which the vertical asymptote would be at the bottom equals 0. Well, that's x equals 4. Okay, x equals 4. If I were to draw that, that's here. Right? Here, I think I'll jump right down here to the domain. Oh, it'll go -infinity until the vertical asymptote, so 4. Then it needs to jump, then it'll pick right back up, and then it'll go. There's the domain. That wasn't too bad. Now the horizontal asymptote, I'm comparing 1 to 1 again. They are the same. So then I take this 2 over this one here. So then this is 2 over 1. That's y equals 2. oh, again, now I can come down here. It goes down forever, comes up until my asymptote at 2, and then it's 2 until infinity. And there is 9.5, day 2.